In this problem, we are given the function y equals x cubed minus 12x minus 5, and we are asked to find the intervals in which this function is increasing and decreasing. So we know that the slope is going to be the way we figure out if a function is increasing or decreasing, since when the slope is positive, that means the function is increasing, and when the slope is negative, that means it's decreasing. And the slope is also equal to the derivative, so our first step in any first derivative test is obviously going to be to take the derivative. So that is going to give us y prime is equal to 3x squared minus 12. And now our next step is going to be to set the derivative equal to 0 and then solve for x. And this is going to be because if you look on a graph, when the graph of the derivative hits the x-axis, that's going to be a 0, so say there are 2 here, and that's what it looked like, then that would mean that until the derivative hits this 0, the derivative is positive and the original function is increasing, and then when it hits this one, if this is the derivative graph, then the function will be negative and start decreasing. So from there we can solve for x over here, and we can first factor out a 3 and get 3 times x squared minus 4 is equal to 0, and then divide that 3 over, we'll be left with x squared minus 4 is equal to 0. So then we'll have x squared is equal to 4 when we add the 4 over, and x will be equal to plus or minus 2, since the square root of 4 is either 2 or negative 2. So our next step, whenever we have a first derivative test problem, we are going to make this table, and the table will always have the first row is our x values, the next row is the y prime values, and the last row is our y values. So for this example, since we're going to start always at negative infinity and then have an interval from negative infinity to whichever x value is lowest first. So in this case, negative infinity to negative 2. Then our next one will be from negative 2 to 2, and our third column will be from 2 to infinity. And so this won't always be the case, but in most cases the graph will change from increasing to decreasing or vice versa. At the zeros won't always, but building this table and including the intervals from negative infinity to infinity and then in between the zeros just ensures that we know the behavior of the graph at every single value, and we don't need to know exact numbers, but we'll know whether or not it is positive and increasing or decreasing. So to figure that out, we are first going to plug in a value between negative infinity and negative 2 into the y prime equation. So I will plug in negative 3 since that is a small number. So we have negative 3 squared minus 12. So y prime is equal to 3 times 9 minus 12. And then we're left with y prime is equal to 27 minus 12, which is equal to 15. And since 15 is a positive number, in this row right here, we can mark this as a plus sign, and then that will signify that since the derivative is positive, the original function will be increasing since the slope is positive. And so we will just repeat that step for all the other columns and rows. So y prime of 0, you can pick any number in the interval, but 0 is just easiest since it will get rid of the values with an x attached to it. So I'm going to plug in 0 for this negative 2 to 2 interval. So 3 times 0 squared minus 12 is going to be equal to negative 12. So now we can see that we have a negative value in the derivative at this point in the function, so that means that the function is decreasing. And now for the last interval, I will plug in 3, just since that's the smallest number I can after 2 on this interval. So 3 times 3 squared minus 12, and that is going to be equal to 15. So now we have 15, which is a positive number, and we can use this to sort of see the behavior of the graph. So I can graph this out right here, and I'll be graphing the original y function in this graph. So we have zeros at -2 and +2. And then from infinity to -2, the graph is going to be increasing. And then this graph can take on many different forms, so this is just sort of general, and it could look many different ways, but the fact that it's increasing or decreasing will remain the same no matter how you draw it. But anyways, so then between -2 and 2, the graph will be decreasing, and then once it hits 2 again, it will start to increase. So the graph will have some sort of shape like this, not exactly this necessarily, but this is what we have determined from the first derivative test, so that can be used to show us the behavior of different functions on a graph.